The story so far. When matter, in any of its three states, gets hot, its molecules go faster and take up more space, and the solid, liquid, or gas expands. When matter gets cold, its molecules go slower and take up less space, and the solid, liquid, or gas contracts. And now, measuring temperature. Can you tell whether something is hot or cold? In that case, decide which of these three bathtubs you'd like to step into. This one, which is freezing cold. Or this one, which is boiling hot. Or this one, which is neither too hot nor too cold. It's an easy choice, isn't it? Well, go on. Step into the middle one. Feels just a bit too hot, doesn't it? Try the other foot. Oh, now it feels a bit too cold. Well, perhaps judging whether something is hot or cold isn't so easy after all. This is because the human body can only notice differences in hotness or coldness, how hot or cold something is in comparison with something else. But even your own feet can't agree about how hot or cold the water in the middle bathtub is. There must be a better way to measure degree of hotness, or temperature as we usually say. What do we know about hotness? Well, when the temperature of something goes up, its molecules go faster. The molecules in the boiling hot bath water are going too fast for comfort. And the molecules in the freezing cold bath water are going too slowly for comfort. If we could only make sure that the molecules in the in-between bath water were going at just the right speed for the human body, you could take your bath. But how can we measure their speed? Molecules are so tiny, we can't even see them, let alone clock how fast they're going. Wait a minute. There's something else we know about hotness. It not only causes a speed up of molecules, but this speed up causes matter to expand. So we could measure molecule speed indirectly by measuring the effect of that speed, the expansion itself. And that's exactly what a Swedish scientist by the name of Anders Celsius did in 1742. He took a liquid that expands quite a bit when it gets hot, mercury, and poured it into a little tube. He then put the tube into some freezing cold water, and the mercury contracted down to here. He decided to label this freezing point of water 0 degrees Celsius. Next, he put the tube into some boiling hot water, and the mercury expanded up to here. He marked this boiling point of water 100 degrees Celsius. Now he had a means of measuring the relative speeds of molecules. In other words, the relative temperature or degree of hotness of things. Comfortable room temperature is 20 degrees. But 30 degrees is a bit too hot. And minus 20 degrees is much too cold. Celsius could even take his own temperature and find it to be about 37 degrees, which, naturally enough, is the ideal temperature for your bath water, normal body temperature. All you have to do is adjust the water to 37 degrees, and you'll finally be able to take your bath, courtesy Anders Celsius and his hotness meter. Or if you prefer the Greek word for hotness, which is thermos, as in thermos bottle, his thermos meter, or thermometer. Is your bath water at the right temperature now? Oh, my. Perhaps you should have taken a shower.